to Unity. We'll take a look at Unity 6. Going to talk about all kinds of fun stuff. I generally don't like to bury myself in the slides, but just in case some of you don't know what Unity is or what we do, we are a game engine. We're the world's most used game engine. It's pretty awesome to see all of the games on the floor made with Unity, all different types of games. We've used in architecture, automotive, and other industries as well, but we definitely focus on games, especially as of late. That's me. I'm Mark. I live in Los Angeles. It never looks like that. You never see the mountains and you never see the snow, except for maybe after a good rain. But it's been 6 years of my life here in Atlanta. I really miss it. Haven't been back in a long time. That was from 93 to 99. I cannot believe how much the city has grown. I was driving through Midtown yesterday and went, you gotta be kidding me. So pretty cool. Super happy to be back. It's been a while. And definitely a lot of stuff that I miss here. So yeah, so super happy to be back. Our motto at Unity is, we believe the world is a better place with more creators. So that's been from the very, very core from our founders. Recently with Unity 6, I don't know if you know this or not, but there's the free version of Unity, and the past it was the threshold of you can keep using it for free until you make $100,000. Now with Unity 6, it's up to $200,000, so you can be even more successful and still be able to use the free version. So yeah, we just believe that the more creators, the better, and that's something that we've been kind of our mantra since day one, actually. Just some dumb but fascinating numbers. 4.2 billion games or experiences are downloaded every month with Unity. I've been in Unity for 11 years. It's been amazing to see this grow from the millions into passing 1 billion, and now we're at like 4 billion times a month someone pushes on their phone or on a console or something and downloads a Unity project. So we support a bunch of different platforms. That's really important. So if you're developing a game, I saw some great games on the floor that some of them are on Steam, but there's also one on Switch, or we're on Steam or on PS5. The nice thing is that you make your game inside the Unity editor, and then you can deploy it to all these different platforms. Oftentimes with little or no work to go to the other platforms. Sometimes you have to do a lot of work with the UI if you're going from a tablet experience to a console with controllers. Obviously there's some different considerations there, different resolutions. If you're doing Vision Pro, which is actually not on this slide, I was trying to find a black and white little logo for that, couldn't find one. But anyway, we are the only way of building a 3D kind of experience, the only engine right now that supports Vision Pro, which is kind of cool. I love my Vision Pro, it's fun, just need to be more content on it. So hopefully some of you all will be inspired to make some fun content for it. So Unity 6, that's our latest and greatest version, and we are super happy to announce that it is going to be released on October 17th. So you'll be able to download the new version, a bunch of new tutorials, a bunch of new assets for it. I'm going to show you one of the coolest ones that we're going to ship, but there's a ton of enhancements for it. There's a new URP sample scene. I'm going to show you that in depth here today. There's a whole bunch of new multiplayer tools, which allow you to get up and running with multiplayer, like literally in 5-10 minutes. I'm going to show you all those tools, or at least some of them. They're, again, really designed for taking all of that really, really hard work that it takes to create a multiplayer game and delivering that to you all. Let's see, from there, if we have time, I'm going to see where we're at with our timing, but I'll try to show you a little bit of our AI tools. Specifically, well, I'll mention Centis and talk about what that does, but I'll actually show you hopefully a little demo of Muse. Muse is like your co-pilot, writes code for you, fixes your code, lets you ask questions on all things Unity. It's trained on, basically everything Unity documentation. It's all responsibly, ethically trained, and so you can use that in your games, and feel free to publish that on Steam without worrying about copyright infringement. It's all stuff that we have license for. And yeah, so I don't like slides, so that's all the slides I have. The next thing I want to show you is the latest and greatest from our demo team. So every year or two, the Unity demo team, they spend that time building a project that really pushes the envelope of what's possible with Unity on a graphical level. Actually more than just graphics, but the last couple versions have really been focused on digital humans, just insane scale. So what you're going to see is a cinematic called Time Ghost. I'm going to show you the video version of it. It doesn't run quite at full speed on my laptop, but this was rendered at 60 frames a second on an NVIDIA RTX 4090. You're going to see some looks like wheat or some blades of grass. There are 12 million of those in the scene, all flowing at one time. That's using entities and dots, if you know what that is. All the dynamics on them are real. If you watch when his feet are colliding with the grass, the blades of grass actually bend and fold or move. There's this huge shot with a big canyon, a big green canyon. You can fly deep into that canyon from the farthest shot that you see all the way down to a blade of grass. It's all real time. You can move the camera wherever you want. All the VFX, the explosions, everything you see is in real time. The last thing I want to say about it is you're going to see some cloth deformation. So there's going to be some guys running, and they've got some cloth that's moving all around. Cloth simulation is very expensive as far as, when I say expensive, I mean like performance-wise. So it's really heavy, really expensive, takes a lot of calculation. And so the cloth simulation on this was to really proof test our Centis technology. Centis is a way that you can take basically AI brains, AI logic, plug it into Unity and have it execute that. So what the team did is they using Marvelous Designer and Maya, they animated about 160 frames of this cloth animation, sent it to this thing that turns it into an AI brain. So it was about 2.2 gigabytes of data. And what it returned is a little 50 megabyte brain that you plug into Centis, which then will simulate any cloth with all of that accuracy, however you pose your character. And the simulation time is about 0.2 milliseconds per character. And so with all the characters in there, I think it was about 0.8 milliseconds to solve every frame of that cloth animation, which is stupidly fast. And it's however you position the leg or the arms, that cloth simulation just works in real time. It's all based on this little AI brain running in Centis. So Centis is a little bit hard to explain, but that's sort of what we're using this for Centis for. So with all of that babbling, I'm going to stop, and here is Time Ghost. Million strands of hair So yeah, that was Time Ghost. There's so much goodness in there. So let's see here. Here it is running the editor, actually. So normally what I would do is give you a full hour breakdown of how that was done. But I actually just got my hands on the project just like a week ago in Barcelona at Unite where we unveiled it. So I got to spend some time and really go through it and see all the cool tips and tricks they did. So next time I come here to Atlanta, I'll be sure to give you guys a full breakdown of all the shots, all the cool tech in there. There's really so much. One of the things that I loved reading some of the comments on the YouTube forums was the reaction to people when he was rubbing his hair like this. It's all real time. You know, the difference between what you just saw and like watching a pre-rendered film when you go to the movie theaters is you can't do this at the movie theater. You can't spin the camera around. You can't look at that from every possible angle and really, you know, tell the story in a different way. It's all linear. It's all pre-rendered. The hair, or all the particle effects, the dust falling from his helmet, that would be something you do in post. A compositor would take care of that. But in real time, you have to do all of that inside the editor and make sure all renders perfectly in real time. There was one of my favorite comments on YouTube when this came out was the demo team was flexing with the hair rub, which I thought was, I was like, yeah, that's cool. You know, I'm gonna steal that one. Yeah, they were flexing. So look at the hair detection or the collision detection when his helmet comes off. You'll see the hair just gently flip back there like that. Pretty slick. And then when his hand runs through like this, if there's another cinematic, the previous work that the demo team did was called Enemies. If you want to see, like, if you're wondering, oh, the face is covered up, they can't do real face. No, just look at Enemies. Enemies, we took a middle-aged female with a little bit of blemishes, a little bit of wrinkles, didn't want some you know, porcelain skin, and just knocked it out of the park. So if you want to see some really cool facial character animation, check out the previous project, Enemies. Both these are on YouTube. Just look up Time Ghost or Enemies on YouTube for Unity. But here, check this out real quick. I'm going to go and just type in groom. And I'll just select his hair groom, and I'll just show you a couple things really quick. So because the hair tools can simulate any type of hair, animal hair, all sorts of cartoony hair, all sorts of different ethnicities, different styles of hair, the simulation tools are incredibly long. There's a lot of settings, a lot of parameters for doing hair. Even things like the eyebrows versus the eyelashes versus the hair, you know, on his head. Your eyebrows eyelashes rather, are very thick. You know, you wouldn't want those flowing in the breeze. That would be crazy. So there's peach fuzz on them. Each one of those different types of hair has very different parameters when we take a look at here. But one thing that's fun to do is, if I just kind of back up a little bit when his fingers are right about there, let's just go down and start to mess with, well, there's a bunch of these parameters here that I can adjust. But the one I'm really looking for is up here a bit. So let's just change the stiffness. And you'll see the way the collision detection changes as the stiffness of the hair kind of goes through the fingers. If I keep it like that. And these are all keyframes, so as I scrub the time up, they're going to go back to the way they were. But it is fun to just see how accurate the collisions are as they go and kind of go over his fingers and under his hand. Another thing that we created, so this is all stock Unity 6, by the way. So everything in here you can do with Unity 6. The hair is a separate plugin that you can download. It's available. It's constantly being refined. So you can find that on GitHub. Just search for Unity Digital Humans, and you can find the hair plugin. But if I go and type in wind, we have two different wind tools or simulations going on. So the first one is this one that's shaped like a turbine. So it's this round wind here, and this is basically moving back and forth. And you can see how that animation is changing the way that hair was moving. I can come in here and maybe just tweak that a little bit. If I go down and just maybe increase the speed or the amplitude, crank that wind forwards or backwards, and you can see how that reacts. Then there's a secondary wind here, which is a more global wind, which is just basically wind coming at them in a straight direction. So you can animate that one going back and forth, animate the other one, and get some really nice results there. So yeah, good stuff there. So crank that up, crank it down, get flow the other way. It's pretty slick, and I mean, this is all real time still just boggles my mind. You know, I'm on a laptop. It is a nice laptop. I've got a 4070 GPU in here, so not too shabby, but anyway, good stuff. So that's all I'm going to show you on Time Ghost. This is definitely more on the high end Your game could look like this if you wanted to, but again, this is kind of just showing you the power of the rendering capabilities of Unity 6. And it's funny because when now his face is funny. When you were all coming in, his maybe it's gonna do it again. There you go. His face would disappear. I'm like, oh no, where did his face go? So
Where'd you put it?
Anyway, sometimes I like to show little fun stuff like that too. The eyeballs are pretty neat. So
is it dying?
Let's talk about multiplayer really quick. So we're gonna go from something visually stunning to something incredibly boring visually, but super important technology-wise. So I'm sure we've all played multiplayer games. I mean, the very first game that I think was made, I think, was Pong, and that was multiplayer. But that was on a single device, 2 people with a controller. There was no networking going on. There was no crowd or no matchmaking, no chat, no voice that had to filter out profane language or anything like that. So all those challenges that we have today with modern multiplayer games, very, very different than those original old school games. When you went to the arcade, we got 2 people playing on an arcade game. But now we want to play with 164 players across the internet in different continents, matchmaking of different capabilities and all that stuff. So that's a big challenge. It's a big challenge of making sure that you're not spending stupid amounts of money sending data that you don't need to send. So with Unity 6, we create a whole bunch of brand new multiplayer tools that allow you to get up and running like in 5 minutes. So it may take me 10 minutes because I'm going to talk and describe what I'm doing at the same time. But just watch how fast I can create a multiplayer experience as well as have a matchmaking and some chat capabilities as well. So I'm going to start off with a stock empty scene. I'm using the URP basically empty template. So we've got our default skybox. I have preloaded a couple packages, which I'll show you what I've done. It's just to save a little bit of time, so I'm not having to spend 2 minutes downloading some stuff. Wasn't sure what kind of internet I have here. But essentially, if I go to Window, and brand new in Unity 6, we have this multiplayer tab. So I'll go into the multiplayer center, and it gives me this little box right here with some puzzle pieces. Look at that, we're fixing some puzzles. And it's saying, hey, what kind of game are you making? What kind of genre? Well, we preset some of these different genres: adventure, platformer, fighting. So if I click fighting, it's going to say, well, how many players do you want in a session? Let's say 4. And as soon as I do that, it fills in a bunch of these checkboxes and gives me some suggestions here on what type of packages or tools I may want to have in my fighting game. Do you want to have voice and text capability? Sure. Unity has a technology called VBox. VBox is amazing for filtering out, during parental controls, filtering out people who are being obnoxious, being super loud, or have their stereo on, or using foul language, whatever. And you can really filter out those types of players with VBox. It all is included. Different types of multiplayer services, and you can see if I change it to say racing. Well, for racing, the gameplay pace is fast. Cheating, mod prevention, super important. Some of these other settings where if I go to an adventure game, well, that's slow paced. Yeah, it's still important not to cheat. In arcade games, well, it's not so important that they cheat. I don't know why. You can change all these if you want, but they're just giving you some presets. And these presets are setting a bunch of variables behind the scene, which again, you can also change. But it's just going to give you a nice little head start so you don't have to kind of deal with these yourself. And a lot of these are for operating costs. When you're dealing with a multiplayer game, generally you're the one that's going to foot the bill to Amazon, to whoever your Microsoft or who's ever hosting your data. You want to send as little code back and forth as possible, but still keep a maximum experience. That's why a lot of these are super important. Distributed authority versus client-hosted, dedicated server, cloud code. Distributed authority is new. Client-hosted is, the bummer with client-hosted is if the client closes their game and you've got 10 people connected, everybody goes poof, and everybody's gone. Distributed authority, not only does it distribute who's kind of running it, it also distributes the load. So there's a wonderful little asteroid shooter, which I won't show you today just with time, but the more players pop in the game, each one of those players controls an even amount of where each asteroid is in the position. So again, it's just not overloading. If that person leaves, those asteroids don't disappear. They just get sent to somebody else. So a lot of really nice stuff in here. I'm rambling a lot, so stop rambling. And I would click install packages. I've already done that because this took about 2 minutes to download and install all these packages. So when you do hit this, it goes to this menu here, Quick Start. And all right, so now what do I want to do? Do I want to play test? What kind of tools we got? I'm just going to do this one here. I'm going to create and open a scene with netcode setup, And I'm going to minimize this just a little bit and just kind of watch what happens right here. And of course, there's documentation and some more larger samples. I'm just going to go with the stock one here. And you can see that really quickly it adds a network manager and this temporary UI in the hierarchy. So close that up. And all it really did is it added this temporary UI and it added the network manager. And so what I can now do is go to Window, go to Multiplayer, and go to my play mode like this. And I need to click on the second character. Now, what's super important, and I almost forgot, is when I did that create me a little scene, it renamed my scene from startup scene or whatever it was called to NGO setup. And so it's really important that you do this step first. Otherwise, it's going to take about a minute longer, probably as long as I'm saying to tell it to redo something. So I'm just going to do this. I'm going to show you how to do this. So we go to Build Profiles. Right now, what it's going to do, it's going to build for me a second version of this game. So I actually have 2 players on the screen at once. But what I need to do here is tell it to build the current open scene, which is this NGO_setup, and tell it not to build the default sample scene, like that. Perfect. That's all I need to do. I'm going to save that change. Now I'm going to add player 2. Because I told it this is going to be a 4-player game, it's going to allow me to create up to 4 virtual players that are all going to run on this laptop. It's definitely better if you have multiple laptops or multiple screens and you're not running at 1024 by 768, which is what I'm running at right now. Or not, geez, that's like old school. Sorry, 1080p, so 1920 by 1080 is what I'm running at. Generally, you want multiple monitors or a higher resolution. This works really well at 4K, but I'm a little cramped for real estate here at 1080p, but I think you'll get the idea of what's going on. So this right here is a standalone version of Unity. It's not the editor, it's actually a version of the game that's running. And so all I need to do now is go into play mode. That's going to start my game, and it's going to take about 20 seconds here to, no, it's not. Sometimes it gives me this little deal where it's going to import some assets, but I guess we're good there. So cool, all I got to do now is close this up, start my host, and it's going to import, or it's going to start my character with a really basic cube. This is our character. This could be something far more exciting than a cube, but right now it's just a cube. So I'm going to minimize that. Let's go here. Let's get rid of that guy too. That's for later. And I'm going to start the client. And if everything goes well, I now have a client who's the red player. It's going to compile the shaders there, and then we'll turn the correct color. So here on the right is player 2. Go back to the editor, go full screen, and here's player 1. And you can see the data synchronized, the character synchronized, and believe it or not, this is actually a true multiplayer game right now. We've actually, just in that little bit of time, we've set it up so this can be multiplayer. But I still have it set up any way for me to join this game, for me to invite my friends, for me to chat, for me to tell somebody I don't like them, whatever. So this is just basically 2 things that are connected locally on my machine. All right, so let's do this. I'm going to stop the game. It's going to stop that other version of Unity running as well. And let's go do this. I'm going to delete this temporary UI that it created for me. So let's just get rid of that. If I go to the network manager and I go to this player prefab, a prefab in Unity is it's an object that you've created that can gain from a complex character to a spaceship with a whole bunch of stuff on it, whatever. It's just a collection of Unity objects that are doing something that's offloaded that can be loaded into the scene. In this case, our player prefab is the cube. That cube right there. Oops, not that cube. Let me double click on it. This cube right here. And so this cube is the cube that we're loading into the scene. That's our basic, super simple character. And that's it. So that's what we're loading up. I could swap this out for something more complex, but I'm just going to keep it as a cube. That at least tells you where the cube is coming from and where you would replace it inside the network manager. So all right, let's go back. Let's go back to our game view. Actually, let's stay in scene view, and let's do this. Let's go game object with nothing selected. So game object, multiplayer widgets, and new for version 6, we have all of these wonderful little widgets, which would normally take you days, weeks, however long to set these up. So the first one I want is, hey, I want to create a session. I want to create a new game that people can log into. Cool. Put that there. And if I click on it here, press the F key, that will frame up on it, and now I can start to build the UI like so. So this is in a 3D view. Let's click on 2D just so that we're looking at this head on. I'll click on the create session, grab my transform tool, and I'm just going to move that to say somewhere right there. I'm going to go back to game object, create a new widget, and let's do, we want a session list. We want to see all the sessions that are out there. This could be thousands of sessions of online games. So we're going to click on that and make sure we select it here. And I'm just going to move it. Oops, sorry. Make sure you do one thing is, before you do that, make sure you select the canvas again. And actually, I moved this and then undid that. So hang on one sec. We'll move that back to where it was. Cool. Click on canvas, game object, widget, and we want to do that session list. Perfect. And then I can move it like this, like so. I can make it a little bit smaller if I want, but that's good. What else do we want? Let's click on our canvas, game object, widget, and let's get the player list. Let's see who all the players that happen to be playing. Cool. So let's grab that one, move it over here, and this one's a bit wide, the width. So let's just change the width to like 400, something like that. That's a bit big. Cool. And just move that over a bit as well. Pick that up. And then the last thing I'll do, click on my canvas again, game object, widget, and let's do, kind of audio systems. I'm just going to do text chat. Great. So let's grab our text chat, pull it over here, bring that down. And this is a terrible design. Obviously, I'm not a great UI designer, but whatever. I want to make sure we can. So because I'm challenged with real estate, I need to keep things cramped in the center because the second window, I lose a bit of real estate. So that's why I'm not spacing this all out, but you'll see. It'll all work. So all right, let's get rid of this guy, hide that. And cool. So I'll save that. I don't actually need to save it. It'll save it automatically, but just being safe. Press the play key, and if all things go correctly, in a few seconds, it will launch my game. Let's go full screen here. Let's minimize that and check it out. My second window here has all that stuff in there as well. So let's go here and say, all right, I want to create a session, and that section is called DreamHack. Great. Probably could increase the scale on that. Click create, and there's my cube right there. Just like we had before, only now it's giving me a name of Sarcastic Winding Bat. So that's hilarious. It just picks random words to call you, and so I'm a sarcastic. That's a good one. All right, so let's go here to player 2 and go full screen, refresh my session list, and check that out. This is actually live on Unity servers right now. I could send you someone an executable of this. They could now join me in real time. The matchmaking would happen using the Unity servers. Click on DreamHack, click on join, and I am now Vengeful Fighting Gooseberry. And he almost spit his water out. So that's funny. So it's Vengeful Fighting Gooseberry versus Sarcastic Winding Bat. And you can see they're both synced up. I go over here, we're moving the blue, all is good. So I can come now to my text window here and say, you stink. That's been my favorite one to type, and well, I went off screen a bit, but it's there. Let's do it here. There it is. You stink. Oh yeah? You too. Whoops, the Vikings win. I don't care. Sorry, good old Windows. I love it when that happens. Anyway, so just that quickly, this is actually a pretty big deal. If you've ever been to a hackathon, nobody tries to do a multiplayer game at a hackathon. Nobody ever tries to do that because it takes the whole hackathon just to get multiplayer going. This is all now live in the time I just showed you, which, believe it or not, is pretty darn remarkable. So hopefully, just using a bunch of really boring cubes and windows and things, we've got ourselves a fun little multiplayer scenario. Show you one other thing. If I go here and let's take that whole canvas that we just created and delete it, and let's go back to window, and we'll go to multiplayer center. And if you click on, so I did this one before, right? Create an open scene with netcode setup. If I click on connecting players, I can say, all right, create an open scene with a widget sample. So great, I don't want to save that. Cool, and now it's created me this, where it did a little bit better job of creating me this UI for me. It's changed the name of my scene to widget start quick setup, so I need to go back in here into my build settings, uncheck that one, and just add the current open scene, which is the one with the new name. Go ahead and save that change. And now if I press play, I can wait just a second, and shabam, if I go here, look at that, updated it just like we have on the other screen like this, except for now, if I create a session, let's just call this DH, I don't know, that's just a random thing, and I create that, and it's going to give me this code here. So let's say I'm still sarcastic winding back, great. Now I can copy this code, and so if I don't want to create a session list that's open to the public, I can just generate this little code, minimize that, go here to my session code, Control V to paste that, join, and now sarcastic winding bat and vengeful fighting gooseberry are together in the same server as well, but I didn't have to actually go through the server list and expose that as public. So this could be a private test session with these wonderful little codes. And I mean, good grief, that was like 5-7 minutes worth of work, and I created a lobby, I created a multiplayer game. Pretty darn cool. So last thing I want to show you with this is, let's go ahead and stop that. If I click on my network manager, I mentioned the prefab, and let's select our prefab. It just selected it for me, so it's an asset. It is my player cube here, great. So let's double click on that guy. And if I open up the inspector here, so these are the network object and the client network transform script, and then these other two here are components that have been added to this cube. And so the ones that are important here is just some of the optimizations you can do for sending less data. So in this little silly little non-game, our cube could move forwards and backwards and left and right. So it could move in X and it could move in Y, but it could not move in Z. It could move in X and it could move in Z, but not Y. So it can't scale. Our object didn't scale. That mechanic wasn't in the game. So you know what? Why am I sending the scale transform every single update, right? That eliminates a whole bunch of data right there. Our cube doesn't rotate. This game doesn't have any rotation stuff. And it doesn't go up and down in Y. So just right there is a big optimization for data. So and there's a bunch of them in here. That's a really simple, obvious one. But you can really start to control a lot of and there's some other places you can go to find some of these things. But as I was setting, whether it's a racing game, an action game, all those little optimizations, a lot of those things you find in here. And then this is just a super simple one to just make sure you're not wasting a lot of money that you don't need to send. Because in multiplayer, data is money, and speed. It's also speed, updates, things like that. So anyway, that's super simple, very fast, multiplayer in a box. It's all with Unity 6, so really good stuff there. And yeah, that's all we're going to take a look at for multiplayer. Let's take a look at some more fun graphic stuff. So this ships actually with the latest LTS version, Unity 2022. LTS is our long-term support version of Unity, which is designed for if you're building a game and you want to stay locked on a version that doesn't get any new features, it only gets bug fixes. We recommend you use the LTS version. And so in the latest LTS version, as also in the latest Unity 6 version, is this project right here, which is our URP sample scene. And it basically just has a bunch of little tutorials that kind of give you a head start of some of the graphical features, kind of show you some of the fun stuff with URP. URP is our universal render pipeline, which is designed for all types of platforms, everything. This project here is designed for everything from iPhone 6 all the way up to like a modern console. And then if you want to do something like Time Ghost, that's HDRP, which is our high definition render pipeline, which turns on a lot of bells and whistles for high-end console and high-end PC. Anyhow, what does all that mean? Well, when you load up this project to begin with, it comes up with this nice little welcome dialog. Actually, you know what? Let me show you really quickly where you get it from. You open the Unity Hub, which is what when you first install Unity, you're going to get the hub, and you click on Add, and I want to add a new project. Click on Sample, and then it's this one right here, the new 3D URP sample, and you'll see these 4 little images. That tells you it's the right one. Click on Download. I've already done that, and then once you download it, give it a name, give it a location, and click Create Project. I've already gone ahead and done that, and when it's all finished and downloaded and everything is compiled and ready to go, it's going to welcome you with a little welcome screen like this, shows you where the forums are at. That's all great. And then it's going to give you these little tutorials. So there's the presentation tutorials, there's graphical features, so if I want to know about graphic settings, volume framework, bake lighting, I'm going to let you play with most of these on your own, and I'm going to show you some of the ones that are not the tutorials, just to show you some fun stuff in here, and then you can download this tonight. This is all ready. You can get this today. Show you some of the fun stuff inside the new sample project. So let's go back. If I click on presentation, it says, all right, let's take a look at some of these. Once you complete the little tutorial, it gives you a little green checkbox, so you can see I've gone ahead and done all that. So before I start, actually, you know what? Before I start, let me just show it to you. Let's do that. So I'm going to click on Game View, go full screen, press play, and this is the terminal. There we go. So the terminal, this particular scene is designed for look dev. Look dev is when you want to take an object that you've created, you've built this wonderful 3D model, you want to see what it looks like with beautiful lighting and shadows, and so just drop it here on this floor and you'll get to see it with nice lighting and won't have to deal with setting up the scene to get that lighting. It's all out of the box for you. And then if we go to the end, this is why we call it the terminal. There are these 3 different hallways you can go to, like you're at a train station or whatever, and it takes you to a different world. Each one of them is different style, different target platforms. These lights are real-time lights, even though they could be baked. There's a nice little tutorial on how those lights work. And what's cool is, ooh, my mouse just spazzed. Very, very sorry. Let's do that again. That was very poorly executed. So without spazzing and you walk into the hall, you get this wonderful little transform. I just love that transition, like so. And then you're in this neat little world called the garden. And if I walk to the end, this is a really wonderful shader graph effect. If you know what Unity is, shader graph is a wonderful visual tool that you can use to design shaders as opposed to writing thousands of lines of code. And this one replicates like an RGB screen up close with like a magnifying glass or something, and then it gives us cool warp distortion. But it doesn't actually put us into the room. So using a couple cameras and a neat little trick, if you walk to the Unity logo, it will magically replace that screen with the actual environment that you can then go in and explore, like so. So this one was definitely designed with Overwatch in mind. If you all play Overwatch, you kind of probably know this this art style right here. What I thought was really, really wonderful. So we've got this wonderful little Japanese tea room, and same deal here. If I go look up at the, oh, man, my mouse is wacky for some reason. Sorry about that. If I look up, you can see we've got a little particle effect as these little petals are falling, and we've got some wonderful real-time lights going on, which are animating. If you look really closely, there's some nice little animation going on there. I love this little river, very stylized as well. That's all done with shader graph and some other neat stuff. And I'm going to take you through a much little in-depth journey on that one in just a second. Let's go sprint. We're just using the stock Unity character controller, by the way, so if you just hold down Shift, it's going to run. Let's go back into the terminal. And I'll run to this guy over here. And this is going to bring up the Oasis, like so. Again, we get a nice little fun transition. Same thing, if I go to the end, I get that cool effect. But I want to look at the Unity logo, be mesmerized. And we are inside the Oasis. So we have this wonderful new eye shader, this new lens flare. Geez, lost my words. We got all this wonderful foliage, which if you look really closely, it's all animating very subtly. All the foliage in here was created with SpeedTree, which is Unity's foliage generating tool. If you're doing anything with plants, like it can create any plant pretty much known to man, create age, it can actually animate the age of them, which is really neat. There's a really beautiful water over here with a subtle kind of animation on there for the reflections and the waves. And then lastly, if I come over here into the tent, when we go into the tent, there's a change of exposure, and we're using that using volumes. So anyway, let's go ahead and stop that, and let me show you some fun stuff that's in each one of those. I'll show you the third scene towards the end. It's designed for VR. But first, let's just go and talk about some of the fun stuff that's in here. So if I click on presentation, the only one of the tutorials I'm going to show you is this first one. Before you start, so it says, all right, well, take a moment to adjust your quality settings for a smooth tutorial experience. So go under Edit, Project Settings, Quality. All right, so Edit, Project Settings, Quality. And you can see I've got PC high, PC low, mobile high, mobile low. And as I toggle between them, you can see that the quality definitely changes. So with PC high, we're getting real-time shadows in here. We're getting real-time shadows in the ceiling. I go to PC low, these are now baked shadows. So they're no longer real time. If I move the light source around, the shadows are not going to update. If I go to mobile low, the quality is even less. Mobile high, similar to PC low, but not as good as PC high. There's this wonderful little water going on here. Again, if I step through them, you can see the quality changes. And then on mobile low, it's about, as least as there's no caustics going on. There's none of that more high-end rendering stuff going on. So really easy to toggle through these different things. And the reason that's important is if you're targeting multiple platforms. So let's say you're making a game for for various phones. And you want to target everything from an iPhone 6 all the way up to an iPhone 16. That's 10, 12 years of horsepower development. So you want to make sure that that game scales. So you would turn off things like real-time shadows. You would turn off things like levels of detail. So your foliage has less leaves, has less complexity. And that's where these little parameters allow you to control a whole bunch of things. And these are 4 that we've set up for you. This add quality level here, I could click on this and say, hey, make me one for Nintendo Switch, where I know exactly the capabilities of a Switch, and so I'll really tune those settings to work for a Switch, versus a PC where it can be all over the place depending on your card, your CPU, and all that nonsense. So anyway, just to show you how easy it is to set some of these things up, let's click on PC Low, and when I do that, I'm going to go to my inspector here, and I'm going to double click on the PC Low rendering asset, click on it here, yeah, perfect. So now, I got this thing here called cache shadows. You can see the shadows are way crummier on PC Low than they are PC High. Well, I'm just going to say, you know what? When I'm on PC Low, I can't do real-time shadows. Let's just say this is like PC Ultra Low. So I'll turn that off. And now as I toggle between PC High and PC Low, we no longer render those real-time shadows. So that's a really obvious one. You can change a whole bunch of different parameters. This isn't the only place where you can set those parameters up, but that's a really obvious one to show. So really simple to set them up and super invaluable so that you don't have to have multiple versions of your project catering to each platform. Just have different quality settings on the same game or the same experience, like so. So anyway, close that up. Let's make sure we're still in PC High. Yes, we are, because the shadows are on. And let's talk about some other stuff on here. So let's go into the Oasis first. Now I can just walk into the Oasis and have it load it. If you go into File, Build, Build and Run, so I want to do a build. I want to build this to my phone. If I do a build from the terminal, it's going to include all 3 of those other scenes as well. That's good and bad. You can do it. What I would recommend is loading each scene individually and just experimenting with them without the overhead or without those other scenes loaded, just so you don't teleport back and forth and get messed up. So we're obviously behind the Oasis. So now I'm in the scene view, which is where I can freely move the camera. We're not using the character controller anymore. And let's just take a look at some of the fun stuff in here. So right after that, I mentioned there was that new lens flare. So let's open up our root. Let's open up lighting, click on our main light. And if I scroll down here, here's the component for lens flare. So obviously I can turn it on and off. But then I can also like crank up the intensity, crank up the scale, really make that ridiculous. The occlusion is kind of neat. So if I turn occlusion on, as I move behind the palm tree, you can see it flicker. I don't recommend anyone look at the sun, but if you do, that's sort of how it works, especially behind a camera. If I turn that off now, it just doesn't care that there's a tree in the way. Less realistic, but maybe you want that. So let's do this. Let's keep going. Let's go forward. I mentioned volumes and how we can have that exposure change when we walk into the tent. That's simple to set up, so I'm going to expand these. So we have 2 volumes. One is the outdoor volume, which, where'd that go? Oh, my gizmos are off. There we go. So that green box is just a cube that we've defined as a volume. So we said, all right, you're in a volume. So anytime I'm in that cube, I want to add this exposure adjustment, I want to add this bloom, and I want to add this fog. And so watch what happens when I zoom in. As soon as I get inside that volume, you're going to see the fog kick on. So there's fog on, and there's fog off, and but also the exposure intensity change. And then if I fly into the tent, we get this exposure change right there. So let's select the tent, like so, and that refresh, great. I'm just going to do something, pretend I'm not doing this, because I did that yesterday, forgot to delete it. So anyway, all right, so if I go out, go back in, there's the exposure, no exposure. So all we're doing there is cranking up this exposure value here. And so it's an override. Just whenever I'm inside that box, you can have as many of these volumes inside of volumes inside of volumes. We're going to get that exposure change. I can increase the fog if I want. Another neat thing in here is that we have this blend distance. So if I set this to 0 and I blend back, you can see the difference. It's very linear. It's either on or off, as opposed to this wonderful blend distance here, which makes it much more subtle and I guess believable. Your eyes just suddenly don't go bonk, and wig out like that, or a camera lens, whatever. And you can add all sorts of different effects for these overrides. So if I go down here to the bottom, add override, let's add some post-processing. And there's a bunch that you can add: film grain, lens distortions, depth of field. I like chromatic aberration because it's kind of funny. It's funny because, you know, there's this tea, right, and some shisha, so maybe when we're in this room, the world looks a bit warped like that. So maybe there's, you know, something's going on with the tea, right? So anyway, I'm not saying anything, and we leave that. We go back in. Hey, give me some more of that tea. Whoa, it's a little longer in here. So anyway, we can add as many of these little fun little effects as you want. I saw some really great uses of them in some of the games out there today and yesterday, so I the day before too. What are these things? There's these little rubber stamps everywhere. Those are called decals, and these are really nice for adding subtle little changes to your scene. So watch this. If I select this decal and move it, whoops, there we go. So if I grab that and move it, it's like spray painting something over top of whatever geometry you already have there. And so me as a 3D artist, this is awesome because, like, I've got multiple objects. I've got the ground, I've got this rug, I've got this other rug. I'd have to, like, generate a new set of UVs for all three of them, or maybe try to get this texture to have some sand, and then this one. Now I just get a decal and just go, I just want to add some sand that covers all that. Not worry about overlapping geometry, none of that stuff. It's just super easy. They're very, very efficient, I should mention. And if I go over here, we've got some more that we're using here to do this. Just add a little bit of dirt that we see right there. So it's just great for just adding some little subtle little bits on there like so. All right, so that's it for the Oasis. Actually, no, I gotta show you one more thing. Actually, I can a whole lot to show. I got this reflection probe right here, and this reflection probe is generating for me a 128 by 128 pixel reflection probe. New for URP is we have a blend distance on the reflection probes as well. So if you have multiple probes, they blend instead of pop, which is nice. We are using this reflection purely to generate the reflection that we see on this water. I have it set to baked because there's no reason for me to generate every single cycle a new image, right? Because, I mean, the trees are gently swaying, but you're not going to notice that in the water where the water's rippling as well. So we're just going to take one capture of the environment and we're going to use that to project onto the water to make our beautiful water look the way it does. And if I show you the water, let's just zoom over here. On key mark, let's zoom in. Oh, shoot. Getting a little ahead of myself. There we go. So we're going to go to the edge of the water. You see we got some kind of subtle transition into the water. The water was made with the shader graph. So if I select my water and I open up this shader, I've got a lot of parameters I can move here. I can change the scaling to be something ridiculous. For the normal map there, that was obviously not good. I could change the strength if I want to get more or less ripple effect. And all of these parameters, including the edge fade, how the field on the side there, where the edge is of the water, all of that is being controlled, as I mentioned, through shader graph. So at shader graph, click on edit. And this obviously looks very complicated. This is how we create shaders now with URP. You can still write code. This is 20, 30,000 lines of code probably to generate all the stuff this shader graph is doing. I don't ever want to write a shader ever again. It's been a long time since I even tried one, and all I could basically do is make like a simple reflection, and then I'm like, okay, this is way out of my league. So now you can use these nodes, and while it looks complicated, it is far more easier to use shader graph to create these shaders. Especially with a little bit of practice, you can do some really fun stuff with it. So here, the probe reflection, we're just reading in that reflection probe that I just showed you, and that's kind of the basis where we're starting. If I zoom out, there's some other stuff going on here. And one of the neatest things about shader graph is if I mouse over these different inputs, you'll see that there's these blue things that are lighting up right here. See that? All right, so every time you want to have a slider, or some sort of an adjustment inside of your shader, you create one of these things. So what does that mean? Well, if I double click here, and we go back to our game view, actually, no, let's just stay here, fine here. So remember I was adjusting some of these parameters. I had normal tiling, normal map strength. Here's the actual normal map, which is an image. Well, if I look over here, normal map is a texture 2D. The next three are floating point. Then we have another, the blend map is texture 2D. Well, look, as I go down here, it's the same thing. The blend map is a texture. The normal is a texture. There's my normal. There's another one. Blend offset speed is a vector. So blend offset speed is a vector, meaning it's going to have an X and a Y. So a technical artist, a technical director, someone who can make these shader graphs often creates them, and then they package them up and give the artist just these parameters to conveniently kind of change and tweak to the scene. So if you're not, a lot of times games are made with teams. So you have some wonderful, very smart shader person writing these nodes, and then you have your artists who don't want to deal with this. They're just moving the sliders and getting the perfect quality of your art stuff. So shader graph is awesome, super fast, and in my opinion, a lot funner than writing shader code. So shoot, I'm running out of time, so I want to show you one more thing in here. Let's go into the Oasis. Let's go into, not the Oasis, I'm in the Oasis. I want to go to the garden. Don't save any of that. And let's see, what can I show you in the garden? I want to show you, why am I so far away? All right, it's going, whoa, no, too low. Where's the garden? I lost the garden. There it is. Sorry, I don't mean to make everybody sick. I'm trying to rush a little bit. All right, so we're in the garden, and again, you can see lots of these rubber stamps. We're using these decals all over the place. These are just so wonderful. I want to spray paint some petals that go everywhere, and also in some places they're not going. So you're noticing they're not going on the water, so you can find kind of how and where they're going. Let's take a look at lighting real quick. So I'm just going to go to this light over here. Yep, this light here. And I'm going to now go into play mode, because that's going to let some scripts start to activate. I'm going to go find that exact same light, which is over here. And if we look closely now, you should be able to see some bugs. There you go. There's some little bugs flying around. And if I go back into scene view, we still see the bugs. And notice we've got a little bit of shimmy on that light. So if I select the light source, check it out. We've got a bunch of animation going here, very subtle. And if I scroll down here, we've got some light flicker going on. So this light flicker is a script which is subtly controlling the intensity and is controlling these parameters here. And just to show you what it's doing, if I crank the scale up, it's just making that light dance around a little bit. Now what's interesting, well, there's a lot of interesting stuff, but what's neat here is this looks like a shadow, right? It looks like that shadow is coming from the way the light is shaped, but it's not. It's just using a cookie. Obviously not a cookie that you eat, but a cookie that changes how the light changes. So these are super efficient. They're not actually casting a shadow at all, so it's not having to compute all that nonsense. It's not using that geometry. In fact, that white thing isn't even being lit up by the light. That's just a white cube with a little bit of a squish to it. There's a light inside of it that's actually casting the light, and then we use this wonderful little cookie to give us that nice little effect right there that looks like we're actually casting a real light source. Last thing I want to show you in here is, let's just step back here, and I'm going to turn off my gizmos, which are those little indicators. And check this out. I'm going to go back to that first thing we looked at, which is project settings. I'm going to go, I got to get out of play mode, sorry. Let's get out of play mode. If you're wondering how, for those of you who use Unity, if you're wondering how I'm in scene view and I'm still moving some leaves, that's because of this guy right here, always refresh. By default, it's off, and then you're like having to move your mouse to get it to refresh. If you've got a lower quality PC or whatever, you want to make sure that's off, but if you've got a nice machine, turn that on, and you'll always see that stuff animating. So if I step between these different settings, you'll notice PC low, no pedals, lower geometry count, no shadows. As I step through the different settings, we've got those various different quality settings going on. So you can see it also controls our levels of detail. And the one thing I really want to show here is if I click on this guy and go to my PC renderer, for those of you that are fairly technical or know the difference between some of these different rendering paths, there has been in Unity forward rendering and deferred rendering. So forward rendering is very efficient, it's fast, but it only allows you to have 8 light sources per game object. Deferred rendering lets you have a stupid amount of lights, but it's much slower. Your frame rates are slower. So some very clever person came up with Forward Plus, which gives you all the benefits of forward as far as performance, but lets you have the amount of light sources and some of that complexity that deferred does. And what I really want to show you here is if I go into my render debugger, 2 things. First, when I go into play mode with my render debugger open, and you find the render debugger under Windows, Analysis, Render Debugger, and then I just always embed it here in the viewport because that's where I like it. Watch what happens right here when I press play. So press play, and suddenly display stats come up. So now I've got this little area where I can see some statistics, frame rates, things like that. But the more important thing I want to show here is if I go to Material, and I go to Material Override, and I click on Lighting Complexity, it does that. Now what the heck is that? So you can see those little numbers in there. Each pixel is lit by some lights. Now, you can't really show a number with a single pixel, so we've divided this up into tiles and put a number on there. What this is showing me is how many lights are rendering those tiles. And this lets me see that with forward plus, okay, I'm using 4 here, 3 here. Watch this. If I go to forward, look how much more lights are required, or how much more inefficient. Forward is the same as deferred. Forward and deferred will use now the same amount of lights, whereas forward plus, way more optimized. So if you're getting close to shipping your game, you're doing those final debugging, you're doing that final optimization, definitely turn on your material lighting complexity and see how that works. So good stuff there. And I'm going to not save that, and let's just see if I can do this in 3 minutes. I don't think I'm going to, but I can't even. I want to show you, hopefully, how I can prototype a game using Muse. So Muse is our online co-pilot, so normally I would set this up a little different, show you the scene first, but watch this. I have a spaceship that needs to move up, down, left, right using WASD. Please make me a script. Great. So it's going to think about it for a second. It's going to tell me I need to start my trial. That's hilarious. I'm logged in. Why is it doing this? Oh, bummer. Okay, maybe I should have not done it this way. Dang it. Well, it would write me a wonderful little script, and what it would do, so it's not even loading up yet. Oh, well. Well, I'm out of time. This is super cool. Either my internet disconnected or no, man, still got internet. That's
the internet here is spotty.
Is it spotty?
Yeah.
All right. So it does require internet. It's trying to authenticate my account right now. Bummer. What this would normally do, so I only got 2 minutes, but and I don't know why the scene is taking so long. It would actually make me a script that I just drag and drop on my. Actually, you know what? As a safety precaution, I already built the script. So I put it here. It's called ship movement. So let's just pretend that it wrote me the script, and I just drag and drop it here, and I press play, and I kid you not, it just returns the code that makes my ship do that. And it automatically gave me a speed value, so I would stop this, and I'd make this like 25, press play again, and move that up and down, left and right like so. Great. If I stop that, let's go to Muse, and let's do Muse chat. And let's just pop this in here, and do I see my history? Oh, my history's there. Okay, so that actually, let's do missile controller. Are you gonna work? Oh, it did work. Okay, cool. Yeah, maybe we can do this. All right, so my first script that it generated gave me that movement. Then I said, okay, cool. I have a game object called spaceship that is moving up, down, left, right. I want to press the F key and have it spawn a prefab from the spaceship's location and have that prefab shoot upwards in the Y-axis. I've already added a rigid body prefab. So it created this code for me. I was like, sweet. So I put it on my spaceship, and I said, all right, well, it only allowed me to shoot one missile at a time. And I was like, okay, I want to shoot multiple missiles. So I said, hey, can you make it so that there's a speed value, because I wanted the missiles to go faster, and it shoot multiple prefab missiles. Got a cut. And I did that, and then I said, all right, well, can you make it so it adds a sound effect to the script? And it did all that for me, and I copied all that, and I said, oh, can you also make sure that it uses 3D colliders? And from there, I went to my thing here, turned on my missile spawner, and I grabbed my missile spawner here, like so. And there was the input for the prefab that I mentioned, so I'm going to put the missile in there, like so. I'm going to take my audio, I'm going to drop it in here, and I'm going to take my audio, I'm going to drop it in here, and I'm going to press play, and then it wasn't fast enough, so that's why I asked it for a speed value. And I had this. And the very last thing I told it was, all right, you know what? I want to spawn some asteroids. I want to be able to adjust the X value and negative and positive, and also the Y value where they spawn. And it created this script for me. And I added all that together, and I had this. And I kid you not, it took me maybe 3 or 4 extra prompts where I had to give it like a little like, hey, you could tweak that a little bit. It just worked. So anyway, I'm a minute over time. I'll be around. I'll go outside if you have any questions. So thank you all very much. Hope this was somewhat interesting. And there you go. Mark S at Unity3D.com if you have any other questions. Thank you all.